Welcome to qnawire.
Okay, so we're in chapter 29, problem 35 here. So we have a short section of wire of length A, and it's moving with a velocity v parallel to a very long wire carrying a current I, as we have shown here. So near the end of the wire section is a distance b from the long wire, assuming the vertical wire is very long compared to the small section of wire. And we want to determine EMF between the ends of the short section, assuming v is in the same direction as I or the opposite direction as I. Okay, so let me go back to black here. So for part A, so how are we going to do this? Well, we know that the magnetic field is going to be perpendicular to the rod at each point from this wire. But we also know as you get farther away from the rod, the magnetic field is going to decrease, and it's going to be proportional to the distance, as equation 28.1 shows. So if we're trying to find the EMF, this is equivalent as integrating over a small segment d epsilon of EMF. But what we can do is we can write d epsilon here as dr, because the normal equation here is given as epsilon is bvl. So if we just integrate dr, with that being a small section of the rod. So if we rewrite this, then we know we're going to integrate from b to b plus a of b v dr. So now we can write b is going to be as a function of r, because we know it decreases as we get farther away from the rod. So if we plug that in, we know this is u naught I over 2 pi r v dr, going from b to b plus a. Okay, well, this is just integrating dr over r, so that's the natural law over the two bounds here. So we get an EMF of mu naught IV over 2 pi natural log of b plus a over b. Cool. So we also know that we can figure out which direction this is going to point, the EMF is, and we know that the EMF is going to point towards the wire in this case, and that's because the positive charges are attracted toward the current. Okay, so now for part B, we want to assume velocity is going upwards or the opposite direction of the current. So now the only direction is, or the only change is the direction of the current. So the magnitude of the EMF remains the same, but it just now points away from the wire instead. So same magnitude points away.